board members here this evening that this particular application has many similarities to a previous application, which I had a copy with me this evening and can't locate right now, but it was 2000. Do you guys remember the one I pointed out? No?
I do remember the case.
I remember the case.
Yeah.
Yeah. Anyways, it was a previous case, and maybe the applicant knows the history here. I know I have a copy of that. I just don't know why I don't have it in front of me at the moment. I may have left it in the truck. But the previous application would have been back in 2000. Was it 2009 when you guys first came?
2012.
2012?
Yes.
I think it was case number 5 in 2012, I believe. And that was like the first application for the gas station with underground tanks.
Yes, Mr. Chairman, members of the board, Morgan Hollis, the attorney for the applicant. We were here before you in 2019, and that was case 2019-5. But at that time, the issue came up of the original application back in 2012. I don't have the case number for that one, but that was for a gas station with an underground storage tank, and it was denied. In 2019, that issue came up, and I presented an argument why it was substantially different from the 2012 case. There were two substantial differences at the time. One was we were asking for an above ground storage tank for the gas station, not a below ground storage tank. And then two, the contamination of the aquifer had occurred since that time, changing sort of the essential element of the aquifer being the water supply for everybody around it. Pennachuck had run pipes. The board discussed the substantial differences and voted to allow the application to go forward, citing that the conditions regarding the aquifer had changed and therefore it should be evaluated differently. So we proceeded in 2019 for a series of variances and special exception. The special exception was to allow a gas station. Because it was an above ground tank, we didn't need a variance. We later came back a month later and asked for a variance for underground piping, going from the above ground tank to the above ground pumps. And a variance for the underground piping was permitted, was granted. At the time, it was 2019 case dash 05A. So it became A to 05. So that was the history. There had been some discussion in 2019 about the issues that were raised in 2012, meaning the importance of the aquifer as the water supply and not wanting to have any underground storage tanks in the area back in 2012. And the decision, as I say, was to go forward as substantial difference had occurred. You may feel the need for the same debate this evening, although I think that was, as I say, resolved by the vote in 2019, indicating the substantial difference was the contamination of the groundwater supply and the installation of Pennachuck water up and down Charles Bancroft Highway. Yeah,
thank you very much for that explanation. I think that's spot on. You put it better than I could have. I did check the minutes and the decision that we issued in 2019, and I feel as though the other criteria for rehearing the case in 2019 was the above ground storage tanks. So I would like to just revisit that as a matter of protocol here amongst the board, where this one is back to the underground tanks and is now very much like that original application. I would like to just review, the criteria that would warrant rehearing the case again here now. I think the contamination and switching all the residences here onto a piping system is still relevant. And then I think there may be some other differences in this current application versus the other one. I'm not sure. I think these underground tanks may be of different construction. Is that also the case, or are we talking the same type of underground tanks as proposed in 2012?
Yeah, I think once we get into the application, and Mr. Chairman, I'll make an offer of proof that Frank Montero, who is I'll use the word renowned because I think he is a renowned expert in this field, will be able to explain the substantial changes in technology since 2012 and what we're proposing as a triple lined with a advanced detection system, substantially different than what was available in 2012. You will, of course, have to hear it and determine whether that protects you enough. But I would offer as a proof that it is substantially different than the technology and the design of the underground storage tanks in 2012.
Okay, very good. And I can also offer as proof that there's been some additional written testimony provided from the Conservation Commission regarding the new proposal. So I think, all of these things factored in, I'd like to at least propose that we, if we need further discussion, we can, or at least make a motion to, move forward with this particular case, the new application, based on the new criteria that's going to be presented, including the contamination to the well. So it's really, changes in technology from 2012. A lot of time has elapsed. The contamination has occurred. That's still relevant. And lastly, some additional testimony from the Conservation Committee, which, I can let you know, it's in 2012, they were opposed. In 2020, they're supportive of the request. So I think all these factors, in my opinion, would warrant us rehearing this case based on what we know about this current application. So if you all agree, do you have a motion? Anybody want to make a motion? Go ahead.
I would make a motion to rehear case
To hear or to
to
accept?
hear case 2020-10 with the updates to the new plan,
Sure,
New design, yeah.
in new design and plan.
sure. I have a motion to accept this application and move forward with the hearing. Do I have a second?
I'll second.
Seconded by Tom. All those in favor say, any further discussion before we vote? Hearing no further discussion, all those in favor say aye. Aye. Opposed? So the motion to move forward with this hearing is granted. So we got that out of the way. Appreciate your patience on that. So with that being said, we'll move forward with hearing this particular application. And we're going to start with you guys presenting your criteria as to why you feel that that this particular variance should be granted. You're muted, I think.
Thank you, Mr. Chairman, members of the board. My name is Morgan Hollis. I'm an attorney with Gottesman and Hollis with offices in Nashua, New Hampshire. And I am here this evening representing Thoreau Properties LLC as the applicant and Thoreau Development LLC as the owner. With me this evening is Renee Thoreau, the representative of both the owner and the applicant. I also have on the WebEx Frank Montero of GPI, and he is going to offer some testimony, technical testimony about the proposed above underground storage tank. Also on is Jim Petropoulos of Hayner Swanson. He is going to put some plans up, and he's available as the engineer should any questions arise about the location of these particular proposed tanks. The property is located at 522 Charles Bancroft Highway. It is on map 22, lot 11 of the town tax maps. The zoning is Northern Commercial District and also the Aquifer Protection District. As I mentioned in the lead up to this hearing, upon question by the chair, I was before you last year's case number 2019-05 and also 2019-05A. And in those two particular cases, first, we asked for and received a use variance to allow a proposed storage facility within the Northern Commercial District. And that's not before you this evening, but I wanted to just refresh your memory. We also needed a use variance to allow the same facility in the Aquifer Protection District. We received grants of variance for both of those uses. We had proposed a gas station, and that's necessary necessary to obtain a use variance in the Aquifer Protection, which we did. As the chair pointed out, that application proposed an above-ground storage tank for the fuel. And at the same time, we needed a special exception for the gas station in the Northern Commercial District. We received the variance for the frontage, as the requirements for the frontage for a gas station in the Northern Commercial District required more footage than we had. So that's what we received back in July. We discovered and realized after the fact that while we had planned for an above-ground storage tank, we had above-ground pumps, and unless we were prepared to have piping go overhead of the pumping facilities, we would need a variance for the underground piping, so it was not allowed. So we came back to the board. We presented the technology of the underground piping and how it was controlled by a shutoff should there be a burst in the pipe. It was a double-line pipe, and I think we made a compelling case that we needed relief. A variance was granted, so we had a gas station, convenience store with a above-ground storage tank and dual pumps out front, and the tanks would go into an underground pipeline and then back up to the pump stations. Since that time, we have been honing in on a better design. What you have in front of you is the original layout of the Farwell design that was presented to the Zoning Board of Adjustment. So you can see on that plan, there's a single building. It was over 9,000 square feet. There was a 3-bay car wash in the back. Jim's arrow's pointing these out if you're able to see it. That there were gas pumps in the front, and then there was a fuel storage above ground, which included diesel fuel. There were 3 tanks shown there where Jim is outlining on the northeast corner of the property. After a lot of discussion with the town and some refinement of working with Hayner Swanson and with Frank Montero, GPI, we've come up with a new plan. We also received some input from several people in town, namely our direct abutter across the street and our direct abutter to the north, that they would like to reconsider and revisit the issue of our choice of above ground storage versus below ground storage tanks. After talking with Frank, we became convinced that the safety factors of above ground versus below ground are equal, that is, in terms of a spill, and putting them below ground increased the safety actually because not only they weren't there so nobody could run into them, they also weren't visible, and I think that was one of the concerns of the neighboring properties. So with that, we have applied for a variance. The first thing we did was take a new look at the site plan, which is what you have before you, and identify that the building is a little bit smaller, a pump layout is different, the car wash is going away. All of these things are different, and we're not here before you for those issues, but wanted you to see what we currently believe, and because it's different from the plan you saw before, we wanted you to see it. This is what we'll probably present to the planning board. There are issues of the site, as you know, and I'll get into them on the 5 criteria, but there's a great deal of wetland surrounding the site and wetland buffers, so we have an unusual piece of property here. We have tried to lay out the storage facility in the back to stay out of the buffers, but there are going to be some drainage facilities that will encroach on the buffers, and we will undoubtedly be back to this board for relief by special exception for those. Those aren't particularly relevant this evening, but I just wanted to paint a clear picture for the board of how far we've come and why we're back to you more than a year later. The first step in proceeding forward is we went to the Conservation Commission because they are a direct abutter to the north. And they also had a great deal of input in our first application to the ZBA. We had gone through the process with them, and they were affirmative, or at least not negative, as to the application for the gas station. So we proceeded back to the Conservation Commission, and at the Conservation Commission, there was a great deal of discussion. Frank and Jim presented, and at that time, the discussion was about the aesthetics and the safety, and the Conservation Commission actually preferred the underground versus the above ground. On this plan in front of you, you will see that the locations of the underground storage tanks have changed. There are two separate locations. One is towards the front of the property. So that's a change from the northern area where they were previously. And one is to the rear of the property. And Jim can highlight where that is. That's where the diesel truck fueling station will be for larger trucks. There'll be a diesel station out front, but the trucks will go to the rear. This is the design that Frank's firm and Jim's firm have come up with as state of the art. So the locations have changed, and the Conservation Commission was very much in favor of us applying for a variance to ask for relief from your board to put these tanks underground. The Conservation Commission has written a letter. I submitted it to the board, and I think they submitted it to the board, but I don't know. Jim, do you have the ability to call that up out of order? Yes. So just for the record, and I'll put it on record, it says Zoning Board of Adjustment is dated December 3rd, 2020. Dear Chairman Riley and board members, on November 5, 2020, the Conservation Commission met with Rene Thoreau, his engineer, Jim Petropoulos, PE, with Hayner Swanson, and Frank Montero, PE, GPI Engineering, regarding the gas station at Tax Map 22, Lot 11. After listening to the extensive discussion with Mr. Montero, the commission voted unanimously to agree that underground storage tanks for the gas station would be much better aesthetically and environmentally. We took into consideration that everyone in the north end of town is now connected to public water. If the applicant went with above ground tanks, there would be considerable visual impact. We are satisfied that the containment with triple walled underground fiberglass tanks and ongoing inspections will satisfy NHDES and aquifer protection. If you have any questions, please feel free to contact me. Yours truly, Joan McGibbon, Chair, Litchfield Conservation Commission. Thank you, Jim. With that introduction, I guess I would also just say, when we went for the variance in September for the underground tanks, this board granted the variance, not for the tanks, the underground piping. This board granted the variance and found specifically that the proposed piping system with containment system and construction techniques would minimize the potential for leaks, which would cause damage to the aquifer. Also, surrounding properties were served by Pennachuck, protecting against threat to the health and safety of the public. So those were findings made by this board as to the underground piping. At this point, I'd like to introduce Frank, because I think he can give you the details. I would also say this, obviously, if a variance is granted, the next approach is going to be we end up having to finalize the plan, identify the wetland impacts, likely come back to this board for special exception application for any impacts that are in the buffer, or else keep them out of the buffer. Then it would proceed to the planning board. Planning board, the ordinance has changed, so the gas stations are now allowed under conditional use permit in the zone. So even though we have relief from you, we will need to get relief from the planning board as well. So no matter what you do here, all of these issues of layout and location will again have to be redecided by the planning board. With that introduction, I would like to introduce, as I say, Frank Montero of GPI, who will give a explanation of the proposed tanks in detail. Frank?
Thank you. Frank, before you start, if I could, just for
Yeah.
the record, we do have a copy of the letter from the Conservation Committee, and that is going to be placed in the file as a matter of record. So that's in there.
Great, thank you.
Go ahead. Go ahead, Frank.
Are you muted, Frank?
You have to unmute.
Zach, can you hear me now?
You gotcha. We gotcha.
Thank you, Mr. Chairman, members of the board. For the record, Frank Montero with GPI. I'm a professional engineer. My office is located in Salem, New Hampshire. The record petroleum engineer on this project, Jim, is proposing to prepare the site engineering for this project. So our role is working with Jim on the fuel storage portion and obtaining applications, submitting applications, obtaining fuel storage permits from the New Hampshire DES. So I'd like to go back to the prior plan, Jim, if you wouldn't mind, the follow-up plan, just to kind of outline the original site layout and a couple components, and then I'll compare it to what's changed. So as Morgan already mentioned, the prior above-ground vaults were located on the north portion of the site there. You could see them. There was 3 vaults shown. The application that was originally submitted, which I read through, was more detailed than the plan shows, but there originally were 3 vaults proposed. Each one was 10,000 gallons for 30,000 gallons of total storage. The main concern with today's gas station designs and fuel consumption by consumers today, we need more fuel storage and a different proportion of fuel grades than what this was originally proposed as. So for instance, today's economy, more people buy regular unleaded fuel than they do super unleaded fuel or the mid-grade fuel. So in this design, originally there would have been 10,000 gallons of regular unleaded, 10,000 of super unleaded, and 10,000 of diesel, which would have required many more deliveries for fuel tankers to keep up with the demand on the regular unleaded. So that's important as related to what we're proposing for new tanks and storage volumes. With larger storage volumes, you have less fuel tanker deliveries, which is a good thing. One other thing to point out, this original design had 4 dispensers under the larger canopy in front of the convenience store, so that was capable of fueling 8 vehicles at one time. And then there was a commercial diesel island kind of perpendicular to that off the end of the island for trucks with 2 fueling locations. There was 1 dispenser in the middle, and the truck with fuel on either side, which is not appropriate for today's vehicles either, and I'll explain the new design for that. But the basic things I wanted to show here were, number 1, the vault location, number 2, the sizes of the vaults. Number 3 was the distance of the vaults to the actual furthest dispenser, the diesel dispenser. So we try to minimize the length of the underground fuel piping between the storage tank and the ultimate dispenser. So the less fuel piping, the less potential for leaks or issues. So under this design, it was about 220 feet between the vault location and the furthest diesel dispenser. I just wanted to point that out for reference. So if we could go to, Jim, your new site plan. So under this, the main objective on this from a site plan point of view was to separate out the truck traffic and the automobile traffic in the front of the site. So we don't want trucks commingling with automobiles. It's not a safe situation. A lot of folks in the vehicles are intimidated by large trucks. So our number 1 objective is to separate the flow. So that's why we're proposing the commercial diesel canopy behind the convenience store, and the retail canopy in front of the store. So any trucks that enter the facility can come in the main entrance to the north end of the site, circulate around the back of the convenience store, independent of the front canopy where the vehicles, automobiles would enter for use there. Trucks would exit into the common exit driveway, and so would vehicles, but it creates separation for traffic flow, much better design in today's marketplace. Couple other points on the new layout. The canopy size for the fuel retail automobiles, it's the same capacity as the original design. There's still 4 dispensers there, which can fuel 8 vehicles at one time. And the diesel, Jim, maybe you can flip to my plan so we'll easy to see the next sheet, please.
Oh, there you
This
go.
is just rotate a little bit, but you can see a little bit better. So again, in front of the convenience store, the canopy's got 4 dispensers. So you can fuel 2 vehicles at one dispenser at a time. So we say that it can fuel 8 vehicles. And then again, to the rear, what you see there is you see 3 islands, and there's actually 3 dispensers on those islands. And this is a much more efficient design than the original design, which just had 1 dispenser in the middle. And the truck would go on either side. So under this scenario, a truck typically has tanks on each side of the cab. So in today's truck fueling facilities, what we want to do is have what we call a master dispenser on the driver's side of the truck and a satellite dispenser on the passenger side of the truck, so that the driver can fill up both tanks simultaneously with high-speed nozzles, so that it's much quicker, and you don't have to throw the nozzle under the truck or pull it around the truck to get to the passenger side. It's just not as safe to fuel under those circumstances. So even though there's 3 dispensers here, I just wanted to point out there's still 2 truck fueling locations. It's much more efficient, high flow, and safer in terms of the filling procedure. Couple other differences when I mentioned the distance for the above ground vaults to the dispensers. Under this plan, what we do is we actually create 2 separate UST locations, 2 different tank farms, we call it. So in the front, there's 2 tanks in the front, very close to the canopy. There's a 20,000 gallon regular unleaded tank, which is the larger tank you see there. And then there's a second tank, which is actually split into 2 compartments. So each compartment's 6,000 gallons. So we have a 6,000 gallon super unleaded, and then we have a 6,000 gallon diesel tank. So by doing a compartmentalized tanks, we can do 2 actual tanks instead of 3 separate tanks, which again minimizes potential risk under the ground with more, less tanks and less piping and less connections. Secondarily, they're very close to the dispenser. So instead of 220 feet away, these tanks are maybe 20 feet from the closest dispenser. Similar at the rear of the site, instead of having a large commercial diesel tank in the front, we choose to put a second diesel tank in the back. And this is a cheaper alternative. This actually will cost more to do. The underground tanks actually cost more than the above ground tanks, but this is all to create a more efficient, safer system for the town. So the back tank system would be a 20,000 gallon diesel tank to service the commercial trucks in the rear. And again, that's about 20 feet off the dispensers in terms of location. And then there's a very small tank next to that. It's a 4,000 gallon. It's actually a diesel exhaust fluid tank, or a DEF tank, we call it. And again, that's a new technology. It's not an additive to the diesel fuel, but it's part of the exhaust emission system, where this DEF fuel gets sprayed into the exhaust stream of the truck, and it makes for a cleaner burn on the diesel fuel. So most diesel trucks that are manufactured today are required to have DEF on board, which is mechanically added to the exhaust system of the diesel fuel. So the truckers that use diesel facilities look for this type of convenience, and in a modern facility, we provide that right on site. Some older facilities, you can buy this DEF fuel in a small def tote inside the convenience store. There's no need to do that under this type of design. So in terms of total storage, with what I've laid out here, in effect, we're proposing 60,000 gallons of petroleum storage in underground tanks. And the 4,000 gallon def tank, which is actually not a hazardous product. It's not regulated by the DES like petroleum is. It's actually a third urea and a third ionized water. So that's actually, we don't need a permit from the state to have that, but I just wanted to clarify what that is on the plan. So this proposed design is 60,000 gallons of underground petroleum storage, which would need a variance from your zoning ordinance. Any questions so far? Let me know if I'm going too fast.
I kind of do.
Go ahead. Yeah, if you wouldn't mind pausing for a moment, I think we might have a couple questions. Go ahead, Al.
So the changes that you've made, have you changed the capacity of fuel that you'll store underground versus what you were going to store above ground?
Yeah, so that was my point. So in the original plan that the board saw, the prior variance, there were 3 vaults, above ground vaults. And I don't know why there were 10,000 gallons each, but there were 30,000 gallons above ground. So if we were going to use vaults, if we were going to use above ground vaults and we needed to get 60,000 gallons of storage, we would need 5 of those vaults, because those vaults, the maximum size vaults that I've seen is 12,000 gallons in size. So we would need 5 of those, which takes up a substantial amount of room, as opposed to these 3 triple wall fiberglass tanks that we're proposing in this.
So in your original plan, it was 30,000 gallons that was going to be stored above ground, or 50,000?
Originally, it was 30,000 gallons on the above ground fuel vaults that the board originally approved.
Okay.
So it's gone up.
That was not involved in that project, so I'm not sure how the 3 vaults was determined. To be honest with you.
And what you're basically saying is that that really wasn't a viable number for the business. This is a more realistic number for the business.
Yeah, so as I mentioned, if with those 3 tanks, if you limited your regular unleaded storage to 10,000 gallons, you would have to make many more deliveries to the site with fuel tankers to keep that tank full.
Yep.
So we try to minimize fuel tanker circulation on site by providing basically twice as much regular unleaded storage on this design.
Okay, thank you. Anything else?
I'm good.
Go ahead. We're all set with questions for now.
Okay, thanks. Jim, if you could go to the next slide, please. We're just going to differentiate what was originally proposed to the board versus what we'd like to do here. So this was a brochure that was included. Well, I'm actually not sure if it was included in the original application. I wasn't involved, but this is the type of product that was described in the original ZBA application. It was a above ground vault, and it was proposed to have triple wall containment. So the way that was achieved in this instance is there's a double wall steel tank. It's actually a square tank that is placed inside of a concrete vault. And the double wall steel provides secondary containment, and the concrete vault provides tertiary containment. And it sits on the ground. And I have some photos to show you what that looks like, but this is what was originally proposed. Some of the downfalls of this, besides the aesthetic part, is whenever you deal with steel tanks, any steel tank subject to corrosion, which a fiberglass tank is not. So that's a very important element for me personally. Any maintenance to the double wall steel tank, you have to send people down into this vault. You physically go down a manhole. And if you have to work inside the tank to repair any equipment, you're going down into a confined space. So that OSHA considers that a confined space entry, so you have to wear oxygen and so forth. So it's a little more difficult. It's a lot more difficult to maintain those. So those are kind of like the main differences or highlights of this system. We haven't, I haven't designed an above ground vault system. I don't prefer them. We have used underground vaults like this where you can put these below grade. Again, they have the same challenges that above ground vaults do in terms of steel tanks and access below grade and in terms of corrosion. And I would not recommend that in this instance either for those reasons. Another option to these above ground vaults, and if you go on the next slide, just in terms of options out there. Well, first, this is an example that I just took offline to show you what one of these concrete vaults would look like. This is not a project that I designed. It's just the product that this company makes. This particular tank here, you can see it sits on the ground. Not the most aesthetically pleasing thing, but some of the disadvantages when you have this, is besides the aesthetics, is you got to provide barricades from physical damage to a truck or a vehicle, so you have to protect it. Vandalism is always a concern, so a lot of times you'll see this with a fence around it to keep folks out. That doesn't necessarily always keep people out, so vandalism is always a concern. Winter weather, rain, heat, and sun, these are all subject to elements. So in the winter, you have to physically shovel these up by hand to gain access to these tanks. Again, and the way these tanks are filled up is there's some type of ladder system where the truck driver, there's actually a fill box on the end of the tank that you can't see. There's a fill box attached to this so they can open it up and fill it up from the fuel tanker. And any maintenance to this vault is done on top. You can see the pipes and pumps and vents come out of the top of the vault. So you have this ladder to get access. This particular photo wouldn't meet today's OSHA requirements. There's no railing around the top of the tank. But I thought it was a good example of what this type of tank gives you. So in this instance, if we were to do 60,000 gallons of storage, each one of these would be 12,000 gallons, which is a little bigger than what's shown here. And you would see 5 of those lined up next to each other. Another alternative to this is this next slide. This is actually a site we worked on in New Hampshire. It was an industrial facility, so aesthetics wasn't a huge concern here, but this does show a double wall steel tank. This is not a triple wall design, it's a double wall design. And the intent of this is to show what a steel tank would look like. You could do triple wall containment on this. That would have to be a dike. It would be a concrete dike wall going around this thing, which would contain any potential leak from the double wall system, similar to the way the other above ground vault worked. But when you get into a dike system, you get into other issues with rainwater accumulation, snow accumulation. And then some folks put canopies over the tanks. And then you get into an aesthetic issue with what you end up with here. And again, this is this was a 20,000 gallon tank in this instance. So if we were to do 60,000 gallons of storage, you'd have 3 of these guys sitting on the ground. The next slide on here, just to show what an OSHA certified access platform looks like. This is one we installed on this tank that has a ladder and a platform or a catwalk on top with a railing. This is what you would need to gain access to the top of one of these tanks to service it. And again, that above ground tank, just in terms of size, is, if we were to do a 20,000 gallon tank, it's 10-foot diameter round, and that one there is 35 feet long. In terms of sizing. This is an exhibit, an illustrative drawing of what we're proposing for this site. And this is an illustration that's provided by Containment Solutions, which is the manufacturer of the tank that we would use. And Containment Solutions is owned by NOV. NOV is the parent company. So typically in New Hampshire, double wall containment is required on UST system. I actually couldn't find a triple wall tank on these folks' website, but this is a double wall tank, and I'll explain the differences. But on a double wall tank, there's an inner tank, and these are fiberglass. There's an inner wall, which is fiberglass, and there's a space, and then there's an outer wall, which is also fiberglass. And that interstitial space between the two layers is monitored with the brine solution, which is outlined in green here. It's a liquid that's filled into this space between the two walls. And there's a reservoir on top of the tank, which is delineated with a letter I there to the right on top. It's like a little dome. That's always full of brine, and there's a electronic probe that sits on top of that that monitors the level of that liquid or that brine in that interstitial space. So if there's any kind of leak from the interior wall, that brine solution will go into the tank, and the brine would go down in that dome, and it would set off an electronic alarm on that sensor, which goes back to an electronic console located in the convenience store, which is schematically shown above there. With the triple wall tank, and we've done several of these triple wall systems, by the way. We've done a couple in New Hampshire with the state of New Hampshire that they've seen and reviewed our design. We've done some in Mass and Connecticut in environmentally sensitive areas. These are not very common in New Hampshire, never mind in New England. But the triple wall tank, which is more common actually in California, where this technology originated. The triple wall tank just adds another layer of protection to this schematic. So there'd be another wall going around the middle wall, another layer of this brine solution, and there'd be another dome on this tank somewhere between the big round manholes that you see on there. So that would be an independent brine reservoir that would monitor, again, the same way, the interstitial space between the second wall and the third wall. So that technology is state-of-the-art technology that we've used in New Hampshire, and was proven in the state of New Hampshire's reviewed and proved that extensively in sensitive areas. And again, that goes above and beyond anything that New Hampshire requires in terms of protection. Are there any questions on that so far before going to the next piece?
I have one question. It's probably asking the obvious, but I'm going to do it anyways because I don't think you said it. That monitoring of that protection layer where you're able to detect if any additional liquid is entered in, I assume that monitoring works in reverse as well, in that if that outer wall was leaking, you'd know that now you're losing volume, and that you've now, undermined the integrity of the system?
Yeah, absolutely. That's a great point. I neglected to bring that up. So if the outer wall of the tank were to crack or leak, two things could happen. If there's a low water table, the brine would leave that outer shell. And again, the brine level would go down and trigger an alarm. And it's an audible and visual alarm inside the store. If there's a high water table, which it could be in this instance because of the adjacent wetlands, if there's a breach in that outer wall of the tank, the groundwater would actually enter that interstitial space and push the brine level up. And that would also set off an alarm and trigger. So excellent question, and that's how it would work.
Any other questions from the board?
I just have one.
Go ahead, please.
And what's the
All right,
guarantee?
so on the,
Oh, one moment, please. I'm sorry. Tom Cooney has a question too.
And how do we know that you don't have a water level that stays even with it, so there is no change?
I don't know if that's possible, is it?
well, I mean,
things
the
possible.
water level would have to be at the exact elevation of the top of that dome
Oh, yeah, you're right.
to not change the control. But during that process, that alarm is going to get sensed one way or another right off the bat when that level changes. It's going to take a while to seek its own level. But as soon as that sensor goes up or down, in any event, that alarm's gonna go off.
It'd be very unlikely that it would be the same level, but I just wasn't sure.
Yeah, I mean, I don't know that would ever happen, but the level in New Hampshire, I mean, the groundwater fluctuates, daily. So, in the spring, you're gonna have higher groundwater levels than in the summer. So it'd be highly unlikely that you'd ever have any level at one consistent elevation, never mind at the top of that dome.
Correct, and I just wasn't sure what the water level was over in that area.
Yes.
Yeah, I don't know if we know that.
Yeah.
Interesting.
Yeah.
Sorry.
So, I mean, it sits in the aquifer, so I don't know if it.
Yeah, I would assume, so, I don't know if I'm asking the question for you, but are you trying to ask whether, what the water tables are like in an aquifer district? Do they fluctuate?
I know
Wait,
I know they fluctuate.
Yeah,
I just wasn't sure what that specific district would be.
Oh.
If normally this would be above the water level or.
Oh,
If I may, Mr. Chairman. If I may, I'm Jim Petropoulos with Hayner Associates. We've actually dug some test pits in the front of the site. Can you hear me?
yeah, we're getting a little echo there, but we can hear you.
That was my next
Yeah.
question.
We did some testing in the front part of the site, in the location of the tanks, the proposed tanks in the front. Those results were we went down 10 feet. We did not hit water in either test pit hole. We had an estimated seasonal high, a staining of soil at 9 feet in one of the pits. But the other pit down at 10 feet had no evidence of any estimated or groundwater whatsoever. So my testimony is the testing we've done to date out there was good testing, groundwater down 10 feet plus in those locations.
Good enough?
Yeah, I
So-
said, I just wasn't sure what.
So the grade that's there now, is that the grade that you're gonna stay at, or are you gonna?
Yeah, essentially, yeah. Pretty much it's a fairly flat site there, so
Yeah.
absolutely.
Okay,
Pretty flat too.
yeah,
Yeah.
it's at road grade too.
Yeah,
so,
exactly.
Yeah, okay.
All right, thank you. Thanks for letting us ask those questions. You can, I think we're all done with our questions for now. And Michelle, I know you're following along and taking notes for our board. If you do need us to stop at any time, please just go ahead and speak up. Ask whatever you need to ask.
Hey, Jim, if you could go to that tank exhibit again. Thank you. So that's good information on the seasonal high water table. These tanks here, as I mentioned, well, maybe I didn't, these would be 10-foot diameter tanks. They'd be buried 4 to 5 feet, somewhere in that range. So the bottom of this tank hole is typically 14, 15 feet deep. So it sounds like the groundwater would never reach the top of the tank, based on Jim's testimony. We designed these tanks assuming a worst case scenario that the water table could rise above the tanks. So for buoyancy reasons, we put these concrete dead men in, which you see on the slide along each side of the tank. So that those are attached to straps that wrap around the tank. It's labeled as K on the far right of that exhibit there. So there's a series of straps that actually hold down the tank to prevent any buoyant action. In the event that the water table ever did come up high and the tank were empty, it's just something we would do normally. In terms of the next safety precautions that are part of this system that we're proposing, the tank sumps on top of the tank, the 2 round larger manholes. The one on the left there, that houses the actual pump. So that's highlighted in red there. So the pump, it's kind of deceiving. Everyone calls it dispensers pumps. In the old days, the pumps used to be up in the dispensers, but now the pumps are actually down under the ground. So that submersible pump goes down into the tank and it actually pressurizes the fuel lines and sends fuel up to the dispenser. So So any of the product piping that comes down between the dispenser and that sump on top of the tank, enters that sump riser on top of the tank, and any potential leakage in that submersible pump is contained within that sump. So that sump is considered secondary containment by the state of New Hampshire. The actual pipe is the primary line that comes into the sump. Usually the line that comes into the sump is single wall. The internal connections, and the sump itself provides secondary containment, and that's what the state required. In this instance, we're proposing to use double wall tank sumps, which is shown in this exhibit. These are double wall tank sumps here. And again, it's showing the brine solution between the walls of the sumps. And it acts the same way the tank does. There's a little brine reservoir that's physically inside that sump that you can't really see. I think I'm trying to show it as D on that diagram, but there's a reservoir that's attached to the inside. It's integral to the wall. And again, there's an electronic probe that's attached to that reservoir that runs back to the same electronic console that's in the convenience store. But the key thing is that we not only have that one sump for the submersible, but we have a second sump that contains the fill pipe that the fuel tank is used to fill up the underground tanks, and the vent extraction pipe, which is the second smaller manhole that you see inside that sump. So on a normal UST system, those pipes aren't necessarily, those fill buckets aren't necessarily housed inside another sump like that. They're usually a direct connection right into the top of the tank without any protection around them. That's not a requirement of the state to have that second sump. The secondary containment is up in the actual bucket up near the surface where the truck driver connects his hose. We call that a spill bucket. So any containment or spill from that connection ends up in that double wall bucket and drains down into the tank. So as a further factor of safety here, we're proposing to use the second sump and put those two, the fill pipe and the vapor extraction pipe inside that sump. Again, it's a double wall sump, so you're in effect getting a triple wall containment in that sump itself. And just to understand the vapor extraction pipe, so when the fuel tanker fills up the tank, the vapors inside that tank, as the fuel enters the tank, the vapors are sucked out through the other line, and the vapors go back into the fuel tanker, and they're condensed back at the refinery into a liquid. And so that's how we minimize vapor releases into the atmosphere through the vents on the tanks, which is a newer technology that didn't exist several years ago. So every time these tanks were filled, you might have smelled petroleum in the air from that displacement. So those are the main components on top of the tank that house the mechanical equipment for the tanks and how they operate. The next piece of the puzzle is the actual fuel piping that connects the submersible pumps, which pumps the product to the dispensers, and how that's done. So the original ZBA application that the board approved specified a flex pipe. It was a triple wall flexible line. I think OPW was the brand. We're proposing to use something different. We want to use a triple wall fiberglass pipe, similar, exact same material as the tanks. The reason why I like to use that is what I think of one of the weakest link of this whole system, which is where the piping enters the sumps, where the piping comes into those submersible sumps on the tanks, and where the piping comes into there's a sump actually under the dispenser as well, which is kind of shown in the schematic in blue. So by using a fiberglass pipe, a rigid fiberglass material, we can physically bond that pipe to the fiberglass at the sump. So there's no flexible connections, there's no rubber boots, there's nothing that can degrade and fall apart and potentially leak. In my opinion, that's the best solution for a tight system. So we would propose a triple wall fiberglass pipe in addition to the triple wall fiberglass tank. Again, the triple wall piping is not a DES requirement. We're proposing to do that here, obviously, because of the aquifer. And again, carrying that thought process up to the dispensers, there's a containment sump under that dispenser. Again, that we're proposing to use a fiberglass sump. The original application that was approved consisted of a polyethylene sump, which you can't bond fiberglass to polyethylene, so you need to use rubber boots. And again, I prefer not to do that. So we're proposing to use double wall fiberglass sumps under the dispensers. Same technology and thought process as the sumps on the tank. The sumps under the dispensers are manufactured by a different company that specializes in these sumps. It's called Bravo. They're out of California. And again, that's where this technology all started in California, this triple wall technology. It's very unusual to have it out east. But again, the double wall sump would have a brine solution in it with a reservoir inside that, with electronic probes to monitor that. It's the same technology as the tank and the stuff. So that basically is how we're proposing to provide triple wall containment on this particular site. Again, it's not the cheapest option out there to get there, and that was kind of the intent of showing you the options and the benefits and disadvantages of each. But just basic, common understanding is fiberglass material does not corrode, and steel does. There's ways to help protect steel from corroding with cathodic protection, and that's what the vaults use. But there's weaknesses to that system, limitations that I'd prefer not to use. So that's kind of my presentation on a high level on how these work. There's several other bells and whistles that go into this UST system. But quite honestly, those bells and whistles would be used whether this is a double wall tank, a triple wall tank. I would say that the underground tank, some of the benefits on spill containment, I think are better. If you have an above ground vault or an above ground tank, the method that the truck driver fills up these tanks, there's a stainless steel box typically that gets mounted to the side of that vault with a cover that flips up, and the hose from the fuel tank, he picks the hose up off the ground, connects it to the box on the side of the vault, and connects it. So it's an exposed box. It's in terms of open to the atmosphere, subject to vandalism, subject to weather, subject to corrosion. I just don't think it's as good as this type of system where in this instance, the below grade box, if you will, is that spill containment box that I mentioned. It's below grade. It's stainless steel. It's not subject to the elements. You don't have to hand shovel around them. You don't have to keep them clear. I mean, the benefit of putting them in the paved areas is that the plow trucks will keep them clear for you. So you don't have issues with field drivers potentially slipping on ice trying to fill these tanks and things like that. So those are little things, but they're important when you're looking at the overall system. So, I mean, there's a lot of studies been done on leaks in the origin of the leaks. State of Florida did an extensive study back, I think it was in 2005, where they analyzed hundreds of convenience stores or UST systems in the state. And I think the numbers were something like 90% of the leaks have nothing to do with the tanks themselves. They have to do with filling of the tanks, entry boots, the piping, and little things like that. And technology that people don't really focus on. They really think like the tank itself is the game changer. But I'm not aware of a fiberglass tank that's failed. These manufacturers warranty their tanks for 30 years. In the state of New Hampshire, let you keep them in the ground longer than that, as long as you do annual testing. So they're proving technology. technology's been around for quite a while in terms of fiberglass. And it just improves over the years in terms of double wall containment, triple wall containment, and so forth. So, in my opinion, this is the safest type of fuel system that you could have in an aquifer. And we have designed it in other aquifers, other communities and states, so it wouldn't be the first one in the workflow. I'll conclude with that. It just at the same question.
All right, I'm gonna ask another probably obvious question, or hopefully it's an easy question. I don't know if you'd be the right person to answer this, but let me ask you along the lines of, comparing the above ground storage versus the underground storage. When I look at risks to risk for leakage, you've talked about the natural decay of the material and how the fiberglass is better than steel. I get all of that, but I think we also, and what we didn't really talk much, you talked a little bit about the other safety precautions that you need to implement for the above ground. You have to put bollards up or security fencing and things of that nature. So clearly the risk to damaging an above ground tank are things like people driving a car into it or vandalism, as you've mentioned earlier. When you put that tank underground, what type of risks exist to that tank once it's underground? I mean, what natural kind of effects outside of aging could possibly damage that tank? Anything?
No, I mean, the potential risks are buoyant forces. I've seen tanks that aren't anchored pop out of the ground. You can see some pretty good videos online of tanks just physically coming right out of the pavement.
Oh, no kidding.
Is that due to the water?
Yeah.
What was that?
Is that due to the high water risk?
Yeah, the high water. So like if the engineer doesn't design it with the anchors that I showed you, because they think the water table's down below the bottom of the tank, well, then they try to save a few bucks. If you get an extraordinary, I don't know, spring and your water table's way up or whatever, the tank could physically come out of the ground. So
Wow.
in my viewpoint, it's not worth the risk. So we inherently design it that way all the time. There's concerns out west with like earthquakes, for instance. It's obviously a bigger concern out west, but these tanks are more prevalent out west than they are out east. So that technology has been improved in terms of flexibility in the lines. That's a key in allowing flexibility. Even with fiberglass lines, they're designed to allow flexibility between rigid points and flexible points through the length of the pipe. So we have these minimum dog legs, we call them, where obviously fiberglass is flexible in a pipe, so you have to design it with certain lengths so that if the ground did move up and down, or frost, the surface moves up and down, the tank's not going to move, it's below the frost. There is some movement in the piping itself, and with the proper design, that's not a problem. So I don't know of any other risks, to be honest with you, other than high water table and earthquakes. I mean, you've eliminated the elements by putting it underground, which is, a big positive in my view.
Yeah, and I think those type of natural risks have some sort of effect even on above ground tanks. Certainly an earthquake, for example, poses the same risk to above ground or underground. So in essence, what you're proposing has less risk, at least from things like people driving a vehicle into the tank or vandalism. It's much more difficult to achieve if it's buried underground. Is that fair?
Yeah, that's correct. I mean, the big one, vandalism is a real one. There are above ground tanks in New England with fences around them, and I mean, the other thing you have when you have an above ground tank and you have underground piping, you have a transition point between underground and above ground. So you have exposed pipelines, you have, you have things that could go wrong, you have things that people could intentionally do if they wanted to that you can't do underground. So there are other, physical risks involved with having above ground tanks relative to the piping itself. You got to provide UV protection if the piping's above ground. I know there's piping out there that doesn't have UV protection. It's flexible piping, and that's at risk. So those are also things to consider with the underground system.
All right. Any other questions for Frank before I go back to Mr. Hollis, Attorney Hollis?
I have one question. So the total height of the tank with the manhole is 14 feet?
Yeah, the tank depth is usually 4 feet and the tank is 10 feet. It might vary a little bit because the piping, but I didn't get into all the details, but the fuel piping between the dispensers and the tanks needs to slope back to the tanks a minimum of 1%. So that 1% slope occurs from the furthest dispenser all the way through all the dispensers and down to the tank. And what that is if there's a leak in the piping, how I mentioned the triple wall piping, basically there's a coaxial pipe. It's a double wall fiberglass pipe inside of a third fiberglass pipe, and that's how we achieve tertiary containment. If there's a leak in any of those pipe walls, the fuel product goes out into the space between the walls and it physically flows back to the sump on top of the tank. And that fluid comes into that sump riser where there's another leak detector in there. That triggers off an alarm. So that's how those triple wall lines are monitored, one way that they're monitored. So that's a long way of saying that we need to slope the pipe down to the tank. So depending on how long that pipe run is, dictates how deep the tank is in the ground. 4 would be the minimum. It's not uncommon to have 5. 7 feet is the maximum that the manufacturer allows on the tanks themselves. So in this instance, the bottom of the tanks would be somewhere between 14 and 15 feet.
So if I heard him right, he said he dug a test pit to 9 feet. That was the seasonal high water level. Was that 9 feet?
Evidence. Yeah.
I believe so. That's what he said, yeah.
So this tank could possibly sit in 6 feet of water at times? Is that the way I read it?
Yep.
Okay.
Yep. Absolutely. Yep. That's why we designed it with anchors to prevent any kind of flotation.
So you probably have to do water pumping while you're installing the tanks, then I would take it.
That depends. Like that's the seasonal high water table. So that's the highest that the water table is probably in the spring.
Yeah.
And Jim determines that with the modeling in the soil. So if we dug that hole in the summer, there could be no water in there. We wouldn't have to worry about it at all.
Yeah.
So that's a worst case scenario during construction. If they were to do the excavation in the spring, they might have to dewater the hole if that were the case.
Would that be the case for both locations of the underground tanks, or are we just referring to that high water mark in one location for the underground tanks?
If I may, sir, again, Jim Petropoulos, as the property falls back from Charles Bancroft Highway, the grade does gently start to slope downward. I believe the tanks behind the building will be in a fill section. So as that land tends to fall away, these gas mini mart sites want to be a flat pad. And so I actually think we will have a greater depth from surface to observed estimated water tables in the back than we would in the front. Additional testing needs to be made. We're hoping we're successful this evening so we can move forward to the actual design part of the project. It's very likely we'll need some additional testing, certainly borings for the building. And we'll also do testing in that second subsurface tank location in the back.
I'll ask the next obvious question then, I guess, just for clarification. Is it is perfectly within tolerances to put these type of tanks in this type of environment where this potential water table or is such that the tank could be in 5 feet of water. In other words, this is not necessarily abnormal, it's acceptable practice.
Absolutely, yeah. It's very common not to find a water table in New Hampshire deeper than 2 feet. So this is kind of, because you're in an aquifer here, your water table tends to be a little lower because it's down, it's a well-graded soil, it's stratified drift. But I mean, there's no restriction on putting tanks in water completely. In fact, we do some down in Florida where we actually float the tanks in a tank hole full of water. You want to see something interesting. So those are actually installed in water. So to answer your question, yeah, it's very common to put any kind of fuel tank in a high water table. And again, that's why we prefer to use fiberglass. You can do double wall steel tanks underground. That's allowable by the state of New Hampshire. You can put double wall steel in the ground in water. And again, those have cathodic protection to keep them from corroding. You can do these vaults like above ground. You can also put them below grade. And you anchor those with a similar type of anchoring system. It's not straps. It's called an anchor collar to prevent buoyancy. But then again, you have a high water table. You have potential penetration points. On a vaulted system, your entry boots that I talk about are actually rubber that degrade over time. So when you have dissimilar materials interacting with each other, you're just looking for problems. So, if you have a concrete vault converting to a fiberglass pipe, you need to somehow connect it. If you have a concrete vault going to double wall steel pipe, you need to somehow connect it. So the best scenario is to have all similar materials, which we're proposing here. And that's why I wanted to point out that this piping is different than you saw before. It's not the OPW flex pipe that was originally proposed. It's a triple wall, rigid fiberglass pipe. So very common to put in water. Doesn't affect fiberglass at all. Doesn't affect the entry boots at all.
Okay, thank you.
So I have one more question. So the salts won't affect fiberglass like they would a concrete tank?
No,
Underground?
they won't.
Okay.
All right, so I think we've moved at least past that part of the technical testimony, and that was excellent, by the way, so thank you for that. Where would you like to go next, Mr. Attorney Hollis?
Yes, well, so as you can see, we knew that if we were coming back to the zoning board on a underground storage versus an above ground storage, we kind of needed our A game. And I've actually learned a great deal from Frank as we've gone through this and even tonight. And I think probably you have. It's totally different technology, totally different systems than before. And I think, as Frank said, we hope it's a better protection, and that's why the Conservation Commission is in support of it. They think it is a better system, but that remains to be seen. It'll be up to you. Mr. Chair, I'll just go right through the 5 criteria now, which I think we can address. And then if any questions come up, we're all available, obviously. But the first criteria is that if you grant the variance, it cannot be contrary to the public interest. And public interest is determined by a lot of criteria, but in this case, the public interest is defined by the Aquifer Protection District, and nobody wants to do anything that's going to adversely affect the aquifer. That's the purpose of the ordinance, restricting underground tanks. Of course, things have advanced some since this ordinance was imposed, and as you've just heard, technology has advanced. But if we put this tank underground, our position is we're not materially altering the character of the neighborhood. That's one of the criteria. You're not going to see the tank instead of seeing the tank. So it really doesn't alter the character. The character of the neighborhood would be unaffected and might even be approved by putting it underground. Obviously, our neighbors think it'll be approved. That's why they asked us. It won't be seen. It won't be exposed to potential damage. That's a triple, not a double. We had originally talked about that. It is flow controls, limiting the amount of the spillage. Frank's gone through that. There's a detection system, sumps detection. There's a pipe detection system. We're proposing better piping than what we received the variance from, according to our expert. So our variance on underground piping stipulated that we had to install as presented. And obviously, we now have advice that there's a better method than what we presented to you, and that's what has been presented tonight. So if you see fit to approve this, I would say you approve the underground piping and the underground storage tank. That's what was requested as presented this evening, not as presented before. There's no real threat to health and safety because we believe we've covered all those bases. I think all your questions have really zeroed in on those issues, and I hope that Frank has been able to answer them. I think one of the things that I did not think of in my arguments in either the application or even in preparation for tonight is this issue of fewer tank deliveries goes right to the public interest. If we're able to have tanks underground as presented, and they're going to be larger than we presented, then those tanks will require less fuel tankers to fill, and therefore greater safety to the public, and it will be in the public interest to approve this variance. Another point that I really hadn't thought of or understood was that this underground piping that was approved by variance was substantially long, several hundred feet, to get out to those fuel tanks. And as Frank points out, all along the way, and as it pokes its head above the ground, each of those pipes has some issue of risk of leakage or damage. Whereas an underground storage tank with complete underground piping, all of the same material as presented, has much less threat. So again, will not be contrary to the public interest. In fact, it will be in the public interest if you approve it. The second criteria is the spirit and intent of the ordinance will be observed. We know that the spirit and intent of the ordinance is protection of the aquifer, and I think we've covered that thoroughly, that we've gone to the end here to try to determine how to protect the aquifer, and indeed, underground protects it better than above ground. So we believe that will not be contrary to the spirit and intent, and same criteria that applies to contrary to public interest applies to in keeping with the spirit and intent of the ordinance. Not out of character, not alter the character, and no threat to health, safety, or welfare. The third point is that substantial justice will be done. The gas station is permitted. We've got the approvals to have the gas station. And in fact, now gas stations are permitted in this zone by conditional use permit by the planning board. So it doesn't even go to the zoning board anymore. But we have a permitted gas station. We have permitted underground lines. We have an above ground storage tank we could put in. I think we've presented to you why we want to go below, both for our safety and our neighbors' safety and our aesthetics. This is important to us, and it's important to the neighborhood, and we believe it's important to the protection of the aquifer. And what you have to do is balance the harm to the public if you grant it versus the harm to the applicant if you don't. And we just don't see any harm to the public. And I think Frank has made a good case of that. And I think the Conservation Commission's letter and its vote of unanimous support of going underground speaks volumes. The fourth point is it won't diminish the values of surrounding properties. Obviously, the best evidence is always what do your neighbors think? Because in most of my zoning applications, if the neighbor doesn't like it, it's because he's worried about the value of his property. And in this case, our neighbor is the Conservation Commission, and they like this. They want this. The neighbor across the street Continental Paving likes this and wants this. We think that this will not only improve the aesthetic view and therefore the values, but improve the safety of the aquifer. As a final best evidence, I asked for and finally received, we were a little late in getting it, but a letter from a appraiser, Chet Rogers, who had previously viewed this project and was surprised to learn about the underground tanks and the safety involved. And he's offered an opinion. I believe I tendered that in, and Jim, I don't know if you're able to call that up, but I tendered it to the town hall late today. And it's a very short letter with a lot of info. Here it is. I'll just read it for the record. In response to your recent request, I'm pleased to submit my analysis of a variance request to allow underground storage tanks instead of above ground tanks in the Aquifer Protection District. This analysis is made to determine what effect this variance would have on surrounding properties. I have performed similar services regarding the subject property within the past 3 years as an appraiser. Site and abutting sites were inspected and photographed on May 13th, 2019. I've reviewed and analyzed the variance application and corresponding zoning ordinance. Surrounding properties consist of conservation land on lot 13 on the road and abutting on the north, plus more conservation land to the rear, lot 10 going back to the Merrimack River. Appears to be an auto service business abutting on the south at the road. That's lot 9, and a Catholic school on lot 100 and behind lot 9. Across the road on lot 8 is Litchfield Sand and Gravel. That would be Continental Paving, with a circa 1879 house in poor condition is likely being restored. I don't think Chet had a chance to visit the site today, but if you all know, it's been restored, and so that process, I think, is either done or near done. There are high voltage transmission lines across the eastern tip of the property. There are buffers on both sides and the rear of the property. This is a very busy street with a variety of commercial uses in close proximity. The subject's gas station would be on the north end of the lot near the conservation land. As I understand it, the tank will not be visible. The tank will be triple wall protected. There will be 2 means of leak detection. This is a tried and true solution, not an experiment. I opine that the proposed, none of the abutters will be impacted by granting the variance to the subject. In my opinion, having no visible tank is better than having a visible tank from a perspective of abutting property values. I opine that the proposed variance will not materially alter the character of the neighborhood and will not adversely impact values of nearby properties. Chet Rogers, certified general appraiser. And then he attached his qualifications and pictures. So that covers the diminishment of abutting property values. The fifth one is the unnecessary hardship argument. As I've argued this case before, this is a unique piece of land surrounded by a great deal of wetlands and wetland buffers, making it a hard piece to work. It is right on the road, a busy road. It's in the northern commercial district, and we think we found a use that marries up with that site. But obviously, because it's in the Aquifer Protection District, we have this issue of fuel lines underground and tanks underground that we have to get over. But we think due to the uniqueness of this site and the fact that it abuts the Conservation Commission and has so much wetlands, that the enforcement of the ordinance to this lot prohibiting underground storage based upon the technology today bears no fair and substantial relationship to protecting the aquifer. In other words, we think you can vary the ordinance and protect the aquifer even better. And I believe we've demonstrated that this evening. New technology, new detection systems, better materials. And now we've heard from Frank how underground is in fact better than above ground. So there's no fair and substantial relationship. And even the Conservation Commission recognizes this with their recommendation to this board. The proposed use is reasonable. Above ground is not as good. Underground is better. With that, I think we've covered all 5 points, 5 criteria. Happy to answer any questions the board may have. Obviously, Jim is here. If you have any questions, Frank remains on, and the owner and applicant is here as well. I thank you, Mr. Chairman.
Thank you. Before we go to the questions, I do want to point out that I do have your copy of the letter from Mr. Rogers, and I will also, with his photos and attachments, I'll put that in the file as well.
Thank you, Mr. Chairman.
Questions?
I think we're good.
So I have a question on the hardship piece. As you pointed out earlier, you actually have the option to move forward right now today with the above ground tanks. So with the approvals you've been given, you literally could move forward today. Is that correct?
We could.
Okay. So explain to me how, denying and I understand the benefits of the underground tanks. I'm trying to zero in on the hardship. Like if we were to say no to the underground tanks, how is that a hardship to the applicant?
So, the hardship argument has morphed a little bit over the years due to the Supreme Court's tinkering with these cases. And the old standard used to be, if you have the ability to use it as it's zoned, then you don't get relief because you have no hardship. That has changed, and it's gotten away from that. So now the criteria is, first of all, you do have to have a unique site, and we've proven that. But most importantly, what you have to demonstrate is that the enforcement of the ordinance on this property bears no fair and substantial relationship to the purpose. In other words, you can't just have an ordinance that if it's applied to the property, it really doesn't make any difference. You're not advancing the purpose of the ordinance. And that's what we're arguing here. We have a unique piece of property, and part of that uniqueness is that we have a gas station we have a gas station, and you got to have these tanks. We're in the Aquifer Protection District. So if you enforce it and say no underground tanks are allowed, it really doesn't bear any relationship to the purpose of the Aquifer Protection District, meaning let's protect the aquifer as best we can. We now have this new technology. We've shown you, and we're agreeing to a condition of approval that it be as presented. And this will, in fact, protect the aquifer more than if you continue to go forward with an above-ground tank. So it's a little bit of a hard concept, and a lot of zoning boards have struggled with it over the last 5 years, but I think more and more people are understanding we have to focus on, does this ordinance and the enforcement bear any relationship? Does it bear a fair and substantial relationship to the purpose of the ordinance? And here, I think we've just demonstrated tonight it doesn't. So what you're doing is regulating something that imposes that kind of hardship. No fair and substantial relationship. That's really the hardship argument. It's not whether you could use it for what you have it for. It's whether the ordinance has a fair and substantial relationship.
Okay. I don't think I had any other questions. So at this point, what I want to do is I'd like to open the meeting up to public input. I know we have no one here in the room from the public. I believe we have no one on the call from the public.
Mr. Chair, I concur. There is no one from the public on.
Okay, so having asked for public input and hearing none, I think we can move to a motion to close public input. So I'll make a motion to close public input. I need a second.
I'll second.
Seconded by Al. All those in favor say aye.
Aye.
Aye. All right, so public input is now closed. What we can do at this point is debate the merits of the application.
Did we receive any other abutter letter?
I did not receive any other abutter letters. We have the written testimony from the real estate representative, and then we have the conservation committee, and that's it. And I don't need to reread since Attorney Hollis
Definitely not.
read it for me. That's great.
It was nice of him.
Yeah, it was.
I just want
It
to
was.
double check to see if there was any other information that wasn't part of the record.
Yep. So why don't we go through I believe I have a pretty good sense of the way I want to vote on this thing.
Well, it is my opinion, I don't speak for the board, but my personal opinion is that what was covered by the attorney, I'm sorry, I forgot. his name.
Attorney Hollis?
Attorney Hollis, thank you.
And the expert testimony?
Is, in the expert testimony is fairly flawless in what I think. I agree with everything that was written on the 5 criteria. There was nothing there that I disagreed with. So in my opinion, that information that was provided can be put in as what I think is the proper response for this variance.
Anything else?
No, I think on that last one where you were questioning on 5, the unnecessary hardship, I think the word unnecessary is important there, that it's not protecting.
Yeah, see, I when I heard the 5th one, the hardship, what he explained was exactly my summary of what I gathered from that. It was well explained, I think, in the questioning.
Mhm.
So I agreed with that and the reasoning behind it. So I felt that it was perfect.
Yeah, I also find favorable here. I think from the get-go, the applicant has sought to address any concerns with regard to protecting the aquifer district. I think they've demonstrated that the technology they're proposing is, the best that they can offer.
Right.
I think they've, clearly sought to alleviate those kind of concerns, and I've clearly worked with our conservation committee to address those concerns. They're really our expert body, and I feel comfortable not only with the testimony that the applicant has presented, but also hearing that type of support from our conservation committee.
Absolutely.
I think their letter clearly states that they took a pretty deep dive into this before they threw their support behind it.
Yep.
So in essence, we're all leaning towards voting to approve this.
Yes,
Right.
and I'll make that motion.
I feel that, well, okay, let's just run through the quick quick 5 points. We don't spend a ton of time on it, but point number 1, variance will not be contrary to the public interest because Attorney Hollis has summarized for us basically that there's a public interest, in fact, in putting these tanks underground.
Yes,
and he's
correct.
explained why.
Yes.
Not just from the newer technology, also the fact that, we've got this water being piped into the area now because that water table was in fact compromised, not by this project, by our neighbors
See, I
across
don't-
the river.
Personally, I don't see any of that being a factor.
All right, I agree.
They're doing whatever they can to protect the aquifer, and by granting the variance, they're actually doing better towards public interest in the aquifer.
I agree with that.
On number 2, sparing of the ordinance is observed because, to me, these are always so
Similar.
linked.
It's true.
I think the exact
Yes.
Same thing.
explanation you just gave for one applies for number 2 in this case. Substantial justice would be done here as they've explained. There is not only the applicant's interest, but there's a public interest in seeing
Safety.
this decision
Yep.
in their favor, allowing those things to go underground. The additional steps and precautions that they're going to be taking through the technology, anchoring everything. All things that they pointed out are not necessarily a requirement,
Nope.
but they're going to make, not a state requirement, but they're going to make it a requirement of this project. I think continues to work in their favor on number 3 too. Number 4, values of surrounding properties are not diminished because, we've got some expert testimony to rely on here. I think, our own personal knowledge, the type of photos that they showed us with these above ground tanks, they're not aesthetically pleasing.
Wow.
I understand the reasoning behind the process that we went through over the years to get here. I understand why the
Because of
decisions were
technology.
made then. And I feel as though at this point, allowing this to go underground with these tanks today would not diminish the surrounding property values. In fact, it would probably be better
Correct,
for the surrounding
correct.
properties. Hardship, we just discussed. I think you mentioned it right at the very beginning of this discussion, so I don't feel a need to get really into it. I think we have enough here in what's been presented for us to author a decision in favor of the applicant. So if someone wants to make a motion to that effect, I'll entertain that. Now, bear in mind, the suggestion was that if we were to approve it, we would be approving the request for the underground tanks
In the piping.
and the underground piping as presented
Presented
here tonight.
right,
Okay,
as designed and presented this evening.
so you want to take a stab at that? Since you're the guest here, you get the shot.
I don't know that I can.
You can do it.
Got it.
What case is this?
This is case 2020-10.
Okay.
10.
That's-
You want a copy of it? I can give it to you. (2020-10). I actually forgot to write that down. That's the cover page.
And what we're actually asking for.
Variance numbers, right on the next page. Okay.
Thank you, that's what I was looking for. Sorry.
Oh, you're good.
I always avoid this part of it. I'd like to make a motion to approve the
Request for variance.
case 2020-10, request for variance from Article 1250 zoning ordinance, subsurface storage and transmission of gasoline fuel in the Aquifer Protection District to allow for underground storage and the underground piping as presented tonight.
Okay, so we have a motion on the table to approve the variance request for the underground tanks, storage tanks, and the underground piping as presented here this evening. Do we have a second? Yeah, do we have a second?
Second.
All right, any further discussion on the motion? All those in favor say aye.
Aye.
Aye. Opposed? Okay, so the variance request for the underground tanks and the piping that was presented here tonight has been granted. So I'm sure you guys know what the next steps are from here. Attorney Hollis, if you don't mind, I would ask that there were a number of slides that were presented here this evening that I don't believe I have a copy of. And I would like to put those in the file as a matter of reference so that, all of that evidence is there should it ever be needed down the road. Is that something you guys could send to me?
Yes, we will. Jim and I will coordinate and make sure we get it between Frank, Jim, and I. We'll get everything to you.
That'd be great. And other than that,
Electronic, okay? If we send the slides electronic?
please, do that. I will, that should be sufficient.
Great. Thank you. Thank you very much, Mr. Chairman and Board. Have a nice evening.
Thank you guys again.
Thank you.
Happy
Appreciate
holidays.
Appreciate, you guys working with the town and really, again, it appears that you've done everything you can to make this project successful
Thank you.
for the town as well. So I appreciate that.
Thank you, gentlemen. Really appreciate it.
Have a good night.
Thank you.
Thanks.
All right. So that business is out of the way. I don't think I have anything else on the agenda today. We
Motion
have
to adjourn?
no elections. We have nothing.
So how easy is it for the public to get into the web days?
They can either telephone in just on a regular old phone. There's a phone number there.
Okay,
And then John would let them into the meeting.
Yep.
Or they can join electronically. And you can do your voice over the internet.
Yep.
You could do a combination of your cell phone and watch it on the
Yep.
computer. So really, it's available to anybody via telephone.
We,
or
when we post
above.
that, it's posted with that phone number, I think.
So my public notices that go in the newspaper has all that phone number information,
Okay.
access codes, passwords. The notices that get published here at Town Hall on the bulletin board and at the library have the same access information in it. And then everything I put on our portal, which is accessible to the public, even my link to the portal, I put on these notices so that they can see all of the evidence that was presented tonight. They would have been able to go to the portal and see.
Yep.
Except for the PowerPoints that he presented.
Okay.
Because I didn't have those, I didn't post those. You know, I only post what I know I have.
I just asked that because, that whole area is kind of a sensitive area to certain people down in there.
Sure.
When they built that new building, the LQ building or whatever, seemed to be a lot of people at that meeting. So I figured,
Thought we might hear more participation.
yeah,
I mean, I've tried to do my best. I actually modeled my notices after I think what Laura sent me, she does for Londonderry. And then also what the town has been using for things like Board of Selectmen and so forth. So I tried to take something and it started out as 2 pages. I got it down to 1, but it has all that information I just told you. And when I'm publishing in the Union Leader, that's why I want to try to condense it as much as possible, but provide all the legalese that we would want in there to invite the public.
So I'll make a motion to adjourn.
I have a motion to adjourn. I'll second that one.
yeah. I'll say that.
All right. All those in favor to adjourn, aye?
I
Aye. All right.
Thank you.
This meeting's